Is HARA the same as TARA? At first glance, they might seem very similar. Both are analysis methods. Both are used to identify risks, and both are essential in modern automotive development. But they are not the same. HARA focuses on hazards caused by system malfunctions. TARA, on the other hand, focuses on threats caused by intentional attacks. So while the structure may look similar, the underlying thinking is completely different, and understanding this difference is critical when working with modern, connected systems. In this video, we explain how HARA and TARA differ, when each method is used, and how they work together in practice. Let's briefly recap what HARA is. HARA stands for Hazard Analysis and Risk Assessment. It is a key activity in ISO 26262. The goal of HARA is to identify hazards that can arise from system malfunctions. So we start with a system or function. Then we identify possible hazards. After that, the risk is evaluated based on three factors: severity, exposure, and controllability. Based on this evaluation, an ASIL level is assigned. This ASIL level then defines the required safety measures. So HARA is essentially about understanding how dangerous a malfunction can be and how critical it is to control it. Now let's look at TARA. TARA stands for Threat Analysis and Risk Assessment. It is a key activity in ISO 21434. Similar to HARA, it is used to analyze risks, but the focus is different. Instead of system malfunctions, TARA looks at potential cybersecurity threats. We start with the system, then identify possible threats. This includes considering how an attacker could access the system and what capabilities they might have. Next, the risk is evaluated based on factors such as likelihood, impact, and attack feasibility. Based on this evaluation, appropriate security measures are defined. So TARA is about understanding how a system could be attacked and how to protect it. Now let's compare HARA and TARA directly. The most important difference is the source of risk. In HARA, risks are caused by system faults. In TARA, risks are caused by attackers. This leads to a completely different perspective. HARA focuses on identifying hazards resulting from unintended malfunctions. TARA focuses on identifying threats resulting from intentional actions. The evaluation criteria are also different. HARA uses severity, exposure, and controllability. TARA considers likelihood, impact, and how feasible an attack is. So even though both methods analyze risk, they approach the problem from fundamentally different angles. The difference between HARA and TARA is not only technical, it is also about mindset. In HARA, we assume that the system behaves unintentionally wrong. A fault occurs, which leads to a malfunction, and potentially a hazard. So the focus is on what can go wrong inside the system. In TARA, the perspective is completely different. Here we assume that someone actively tries to exploit the system. An attacker identifies a weakness, finds an attack path, and creates an impact. So instead of asking, "What if something fails?" we ask, "How could someone break this system?" This shift in thinking is essential for understanding cybersecurity. So how do HARA and TARA work together? In modern automotive systems, both methods are applied in parallel. HARA addresses risks caused by system faults. TARA addresses risks caused by cyber attacks. These are two fundamentally different sources of risk, but both affect the same system. The results of both analyses influence the system design. For example, safety requirements and security requirements must be considered together. Only focusing on one aspect is not sufficient. A system can be safe, but still vulnerable to attacks. Or it can be secure, but unsafe in case of failures. So only the combination of both approaches leads to a safe and secure system. So instead of asking, what if something fails? We ask, how could someone break this system? This shift in thinking is essential for understanding cybersecurity. Let's look at a simple example. Consider a vehicle braking system. From a HARA perspective, we analyze what happens if the system fails. For example, a sensor failure could lead to an incorrect signal, which results in the brake not being applied. This creates a hazard. From a TARA perspective, we look at the same system, but from an attacker's point of view. An attacker could gain access to the system, manipulate signals, and again cause the brake not to be applied. So the outcome might be similar, but the cause is completely different. And this is exactly why both HARA and TARA are needed. There are several common mistakes when comparing HARA and TARA. One of the most common is the assumption that both methods are interchangeable. But as we have seen, they address completely different types of risks. Another misconception is that cybersecurity is not relevant for safety. In reality, a successful attack can directly impact system behavior and lead to safety-critical situations. Some also believe that performing only one analysis is sufficient. But both HARA and TARA are required to cover all relevant risks. And finally, the same evaluation criteria cannot be used. Each method has its own logic and its own approach to risk assessment. Let's summarize the key points. HARA and TARA address different types of risks. HARA focuses on hazards caused by system failures. TARA focuses on threats caused by intentional attacks. They use different methods and different evaluation criteria. But in modern automotive systems, both are required. They are not alternatives, but complementary approaches. And only by combining both can we ensure a system that is both safe and secure. If you want to go beyond this comparison of HARA and TARA, we offer comprehensive online training programs on our website. These self-paced courses cover ISO 26262, ISO 21434, as well as detailed deep dives into HARA, TARA, and ASIL. The focus is not only on understanding the concepts, but on applying them in real engineering projects. You can find the link in the video description and also in the pinned comment below. If you found this video helpful, feel free to give it a like and subscribe to the channel. We regularly publish content on functional safety, cybersecurity, and other engineering standards. Thank you for watching, and we look forward to seeing you in the next video.